This is E.MALARVIZHI. This video is brief about stick diagram. Overview of this video. What is a stick diagram? What informations we can gain from this stick diagram? What are the notations used to draw the sticks? How to draw stick diagram using simple steps, and some sample diagrams using static CMOS logic. First, see what is a stick diagram. Stick diagram is simply skeleton or abstract model for the layout diagram. It is defined as stick diagram is means of capturing topography and layer information using simple diagram. It conveys layer information through color code encoding or monochrome encoding. It acts as an interface between symbolic circuit and the actual layout. The informations gained from the stick diagram is it provides the components and vias present in the circuit. Via is a vertical interconnect axis. It is used to provide the electrical connection between the layers. These are the conducting wires or traces in the circuit. Stick diagram provides relative placement of the components and not exact placement of components. It helps to design layout and routing of the circuit. It doesn't provide any information on dimensions of the component. Example, transistor sizes, length and width of the wire, tub boundaries, etc. It doesn't provide any details on parasitics of the circuit. See the notations of stick diagram. First is metal. Metal drawn in blue color. If you use only one metal, we can use blue color. We can use more than one metal also. It is depends upon the application need. Polysilicon, it is drawn in red color. It is used to construct gate of PMOS and NMOS transistors. N diffusion drawn in green color. P diffusion is drawn in brown color or in yellow color. Some designers are using brown color to draw P diffusion, and some designers are using yellow color to draw P diffusion. Buried contact. Buried contact is used to provide the contact between the polysilicon gate material and the junctions. Next will be contact cut. It is used to provide the electrical contact between different kind of materials or different kind of layers in the circuit. In the right hand side we have dotted lines, solid line, broken lines, etc. These are gray lines. These are otherwise called as monochrome encoding used in stick diagram. These are some of the color codes and symbols in the stick diagram. I have used very few notations in this slide. P diffusion, it is in yellow color. N diffusion, it is in green color. N well, it is in gray color. Especially you can see metal 1 and metal 2. These are with different colors, and vias also we can use more than one via. This is via 1, it is drawn in black color. Via 2 is in yellow color. This is gate oxide layer, and this is example for a transistor. This is a PMOS transistor. This is P diffusion and this is polysilicon. So this forms a PMOS transistor. Next is important points to be noted to draw stick diagram. The first important point is we can connect uh, same type of material, if same type of material or layers or sticks are touch with each other or cross with each other, it establishes electrical contact. In the second set of diagram, we have different type of layers or sticks. They are touch with each other or cross with each other. It doesn't provide any electrical contact between the layers. To establish electrical contact, we need to insert contact cut between the two layers. This black color solid circuit indicates the contact cut to provide electrical contact between different kind of materials. Third important point to be noted is demarcation line. It is used to separate P diffusion and N diffusion in the circuit. That is, it is used to avoid touching of PMOS and NMOS transistors. In this case, the PMOS transistors are aligned in one side of the line and the NMOS transistors are aligned in another side of the line. These are the diagram steps. To start drawing stick diagram, these are the most important points to be noted. Draw 4 horizontal lines. 2 lines are metal lines and 2 lines are P diffusion line and N diffusion line. The top line and bottom line are the metal lines drawn in blue color. The top line is applicable for VDD and bottom line is applicable for VSS or ground. The middle two lines, P diffusion drawn in yellow color, N diffusion drawn in green color. Now, to form a gate, we need to know the number of variables in the given expression or static CMOS diagram. The number of variables will be equal to the number of PMOS transistors used in the circuit and NMOS transistors used in the circuit. So, number of variables will be equal to the number of gates available in the circuit. So, draw vertical lines to form polysilicon gate. This is drawn in red color. Next step, connect topmost PMOS transistor source to VDD. This is available in the pull-up network, and bottommost NMOS transistor source to VSS or ground. This is available in the pull-down network. You know how to draw pull-up network and pull-down network for the given expression. This we can see it later in this video itself. Always tap the output between the pull-up network and the pull-down network. In pull-up network, the bottommost PMOS transistor drain is taken for consideration, and in pull-down network, the topmost NMOS transistor drain is taken for consideration. Here transistors means we have parallel connection of PMOS transistors and parallel connection of NMOS transistors. In the pull-up network, parallel PMOS transistors means all the sources are connected to VDD. In the bottom pull-down network, the NMOS transistors are in parallel. Then all the sources are connected to the ground connection. Next, we need to identify all the terminals of the transistors, PMOS transistor and NMOS transistors in the circuit. Based on the previous two steps, we can easily mark down the terminals of the PMOS and NMOS transistors. These are very helpful to draw stick diagram of a given expression or given circuit, static CMOS circuit. Now see the example for static CMOS circuit and the corresponding stick diagram of the circuit. The first example I have taken static CMOS inverter, and this is the very basic circuit. You know the expression for a static CMOS inverter, y equal to a complement or a bar. That is, the given input is inverted through this static CMOS inverter. You count the number of variables in this expression, only one variable, so it is enough to use only one PMOS transistor and one NMOS transistor. Connect PMOS transistor in the pull-up network. Pull-down network is NMOS transistor. Source of PMOS transistor is connected to VDD. Source of NMOS transistor is connected to VSS. The output is taken between two drains of the transistor. Here the notations are given. Source is connected to VDD. Source of NMOS transistor is connected to ground. By default, the remaining terminals in the transistors are drain terminal. Tap the output between the drain of PMOS and drain of NMOS transistor, and this is said to be the polysilicon gate. Here PMOS is denoted in yellow color and NMOS transistor is drawn in green color. This entire diagram is transferred as a stick diagram here. I told we need to draw 4 horizontal lines. This is the top line and this is the bottom line. The top line is applicable for VDD, bottom line is applicable for VSS. In the middle, 2 horizontal lines. The second line is applicable for P diffusion and third line is applicable for N diffusion. You know P diffusion is drawn in yellow color, N diffusion is drawn in green color. Now as per this circuit diagram, you give the connections here also. Here source of PMOS is connected to VDD. This source and drain terminals are interchangeably used in the MOS transistors. Here source of PMOS is connected to VDD. Similarly, source of NMOS transistor is connected to ground. This vertical line indicates the gate of PMOS and gate of NMOS transistor. Here we have a plus symbol. This plus symbol is indication of a transistor, PMOS transistor, and here this plus symbol is the notation for a NMOS transistor. Now to connect different kind of layers or different kind of sticks or different kind of material, we need to use contact cut. This is the contact cut used to establish or provide electrical connection between the metal and the P diffusion. Likewise, here also we are connecting different kind of materials, so we need to use contact cut to provide electrical contact between N diffusion and the metal. While coming to drain, that is both the drains are connected together and we are tapping the output at the middle of this circuit. So both are different kind of materials, so this contact cut and this contact cut is used to establish or give the electrical contact between the different kind of sticks. Here the center line is said to be the demarcation line. It is used to avoid provide the separation between PMOS transistor and NMOS transistor, or it is used to prohibit the touching of PMOS and NMOS transistors. So this simple diagram is a stick diagram for a static CMOS inverter. Next, this diagram is also a static CMOS inverter stick diagram. The only difference between the previous diagram and this diagram is contact cut. Here the contact cut is drawn as a cross symbol, black color cross symbol. This is also used in this stick diagram. This notation is also used in this stick diagram. Next will be this inverter circuit. This is also stick diagram of a inverter circuit. Here to show the depletion type MOSFET, I have included this diagram. Here this yellow color square box indicates the depletion mode of device. Next is stick diagram for 2 input NAND gate. You know the expression for a 2 input NAND gate, y equal to AB whole dash or AB bar. So we need to draw static CMOS circuit for this expression. You know the static CMOS logic is consisting of pull up network and pull down network. If the variables are in AND operation, connect PMOS transistors are in parallel and NMOS transistors are in series. Based on this, the static CMOS diagram drawn, based on this the CMOS diagram drawn over here, and here we have stick diagram for the corresponding 2 input NAND circuit. Here we need to designate all the terminals, then only it is easy to draw stick diagram. Here the source of 2 PMOS transistors are connected to VDD, so that these two are the sources of 2 PMOS transistors, and drains of 2 NMOS transistors are connected to output. So we are connecting 2 drains of PMOS transistors to output. And similarly, while coming to bottom of the network, source of NMOS bottom NMOS is connected to VSS. So this is the bottom NMOS. This source is connected to VSS, and drain of the top NMOS is connected to output. This is your B transistor. So drain of this transistor is connected to output. So this is the complete stick diagram of a 2 input NAND gate. Next is 2 input NOR gate. The same procedure is followed. Here the expression is y equal to a plus b whole dash. I told you need to count the number of variables. I forgot to tell in the previous case. Here the number of variables equal to 2, a and b. So we have drawn 2 vertical lines. For any stick diagram, the horizontal lines are same. That is, the number of horizontal lines drawn should be 4. Depending upon the number of variables, the number of vertical lines will be varied. Here 2 number of variables, so 2 polysilicon sticks are drawn. Similarly, here you need to mark down the terminals of the transistors. Based on this, this stick diagram is formed. Here this diagram is dual of your previous NAND 2 diagram. That is, in top of the circuit we had parallel PMOS transistors, bottom we have uh, series transistors in the previous case, whereas here the top of the circuit is series transistors and bottom circuit is parallel transistors. So here the output is taken across the drains of both NMOS transistors. So we have marked down the terminals like this. To avoid the length of layers, we are using the notations like this. If we use the drains on other side, the length of the metal layer will be increased. Always we have to minimize the length of layer length. Accordingly we need to place the terminals of the transistors or any other devices. Next is stick diagram for a 3 input NAND gate. You know the expression for a 3 input NAND gate, y equal to a dot b dot c the whole bar. Here number of variables equal to 3, so 3 vertical lines. These are the gates of PMOS and NMOS transistors. Then the top of the circuit, PMOS transistors are connected in parallel because this is a AND operation. If the variables are in AND operation, the transistors are connected in parallel in the pull-up network. If the that is, the transistors are connected in series in the pull-down network. Now we can mark down the terminals. Accordingly we can give the connections. This diagram shows the actual connections of the given circuit. So here if you see the length of the metal used in the output, this is a longer path existing between the drain of PMOS and the drain of NMOS. To avoid this length of the metal, this diagram is showed. Here if you reverse the order, that is ABC are reversed, then we can minimize the length of your metal for taking the output. That is the only difference between the previous diagram and this diagram. Next will be NOR 4. This is a 4 input NOR gate. The same procedure is followed here also. The number of variables equal to 4, so 4 vertical lines. The remaining steps are same. This is example for a complex function. The function is f equal to ab plus ac plus bc. If possible we can minimize the given expression and we can draw the stick diagram. So the expression is simplified into ab plus c into a plus b whole dash. This is also a complement function. You know the static CMOS implements only complement logic expressions. So this is the diagram for this complex function. You can analyze this using the same procedure. Next, stick diagram of a transmission gate. You know the symbol of a transmission gate. This is parallel connection of PMOS and NMOS transistors. The advantage of transmission gate, it can provide strong 1 output and strong 0 output. Here we are using 2 control inputs, C bar and C. One is complement with another control input. So we have connected one control input to the VDD line and another control line to the VSS line. Then the remaining connections are here the transistor, PMOS transistor terminal and NMOS transistor terminal are connected together in the left hand side. The same thing is applicable here. Likewise, that is, we are using metal to connect PMOS terminal and NMOS terminal. Similarly, in the right hand side, we have connected PMOS terminal to NMOS terminal. So these are the different kind of materials, so that we have used metal to connect these two transistors, that is, these two terminals of the transistor. Up to this, I completed this stick diagram. Thank you.